All right.
Well, hold on. Let's.
Right.
Okay, hello everyone. We are doing a design review about the compiler, and Christopher is sharing something here. What are we looking at?
Right. So the main thing we're looking at is stuff with compiled components, which is basically a thing for having compiler-based Paclets, and also just generally being able to. It's basically the package system for the compiler, and it also lets you do these sort of Paclets whose implementations are sort of done in the compiler. But there's also this other thing that's, I think, a much quicker topic. That's this down values function thing that I think we should probably talk about first.
Okay.
So yeah. So basically, right. Let me see if I can introduce this. So basically, the idea is we have this thing called kernel function, which basically lets you, in the middle of your compiled code, you can write kernel function, and this basically tells it this is a function whose definition, where the implementation of the function is just, it's going to call the evaluator, right? And this is sort of the syntax for it. You sort of say, you give it a type, and then you apply it, and there it goes. So the proposal, and there are a few different parts of this, but the first part to mention is to have this thing called down values function, where it's like kernel function, except I'm not sure why it's not. Oh yeah, it's just syntax highlighting being strange. Yeah, it's the same as kernel function, except instead of actually calling the evaluator, it will at compile time read the down values for this and compile the
try
down
and
values.
suck them in and compile them. Nice.
Right. So the example is, here I've got this thing. I can compile it. It's compiling. I can run it. There it goes. I can do the same with the kernel function, and it will give the same result. But just to prove that it works, I'm going to modify the function. And you see the compiled one, it doesn't know about the modification, but the kernel function does. Right? Because this was compiled before I modified it.
This seems nice.
Right. And so,
yeah, go ahead.
Well, okay. So probably going to talk about the name at some point, but right. So this is a pretty uncontroversial thing. The more complicated part, but this is the reason this was initially being introduced, was basically how you write function declarations whose implementations come from down values. So currently,
hold on, let me ask a different question first. Yeah. That's down values. What about sub values and things like that? I mean, what if you had something that
I don't think they're impossible, but they require thought and work. So
it's a different function. So we would have a sub values function.
It would be something different. Yes.
The point is that this sub values are not actually functions, right? Sub values are like sub values objects. They're objects, which sub values can be.
Maybe, right? Christopher. I mean, another way of thinking, they are functions, but they just have some of their arguments in a funny place. That's another way of thinking about them. So,
right, but anyway, the basic point is this function is specifically intended for down values, and if we want to do any other kind of values, it's going to be a different function in the same family.
Right. I think if we had other kinds of values, then it would probably need slightly different syntax. So that would, right. So the reason though why this is sort of important and not just sort of a nice little feature is basically how you define function declarations who get their definitions from down values. So right now this is the documented syntax for doing that. So essentially you have a function declaration, you say, call it foo, and then you say typed, and then instead of writing a pure function, you just write a symbol, right? And then that will get the down values from that symbol. So the proposal.
I don't even understand. Function declaration is as a sub value has test func. What is it?
No. So
what's the @ sign doing?
The @ sign is with the typed. So let me show you what this. Oh, my keyboard has suddenly stopped working. Oh no, it's back. Okay, that's scary. Yeah. So normally this is what you write. Whatever. Right. So normally what you do is you write, here's a function name, here's the type signature, and then here's the function to compile. Right.
So you apply the type signature to the function?
It's an operator form. You can also write this.
I see. Okay, fine.
Right.
Fine.
So yeah, it's just a convention. I usually use the operator form.
It's not a bad convention. I think
No, it's fine. I just wasn't used to it.
Good.
Yeah. So in any case, the point is here is that this is what we do right now is you just give it the symbol and it says, okay, if you give me a symbol as the implementation, I'm going to assume that that symbol is, a down values thing. The proposal is to switch it. So because there's actually another usage of this syntax I think would make a lot more sense. So that instead, the way you do this is you use down values function. So you basically say function declaration, and then the implementation of the function, instead of giving a pure function, you'd say down values function of test func or whatever.
Okay, but that typed wrapper around the down values function is exactly the same thing that you would have used in the usage above, right?
Yes.
Okay, so the issue here is whether that wrapped down values function is, so normally function declaration is given a pure function.
It's given a typed pure function. Yes.
What's the foo? I don't understand. Why is there both a foo and a down values of test func? What is the foo doing?
The foo is the name of the function we're declaring. So see, here's the actual program we're compiling, and it's calling foo. Right.
Yeah,
so
what does that have to do with down values of test func then?
Sorry.
That's where the implementation of the foo function comes from.
I see.
Right. There are two parts. This is the name of the thing. This is the type of the thing, and this is the implementation of the thing.
Right.
So the point is just whether the implementation spec is a symbol or down values function of a symbol.
But in a sense, it's like a module defining a function here. I mean, you're temporarily defining the function foo equals essentially test func with various types specified.
Kind of. I mean, but this is just the normal syntax for function declarations. Like the fact that it's local and so on doesn't really matter here. But yeah.
So it's just a function declaration that says this function named whatever in the compiler environment will have an implementation that is this thing that's specified.
Right. So really the only change here. So, okay, the basic point is here's the schematic of a function declaration. We've got the name of the function that we're declaring. We've got the type of the function we're declaring, and we have the implementation of the function, right? So the question is, the name spec is staying the same, the type is staying the same. The only question is how the implementation spec
What do you want
parsed.
the thing to be when it's just a pure symbol there?
Right. So that's this next section. So basically the idea is, let me see, where's the clearest example? Okay, well, let's just look at this one. Basically, the idea is if it's just a pure symbol, it'll assume that the implementation is just another function in the compiler environment, as opposed to it being, a function in the symbol table.
It can know whether I see it. It will only look for things in the compiler environment.
You really don't want it to say, plus, and then it says,
what's the scoping of the symbol names in that compiler environment?
They're just symbols. So, it's just, if you write this in a package file.
Yeah, symbol scoping uses context and whatever.
Okay, but so it doesn't have it. It's not a scoping construct.
No, not at all.
Okay. So there's symbols globally hanging out there, even though they're ultimately only used in the innards of the compiler.
Well, you could
but you write this in a package.
You put this in module or package or something, that's, and in fact, that's kind of what we're doing with the, the Paclet thing. But they're just symbols.
So to justify this though, because the reason why this syntax is very nice is because it means that there's a whole sort of consistency thing where, right? So suppose, okay, so here I'm going to declare a function in the compiler environment, right? So here now I've got some function in the compiler environment called my function. The point is I want to write this, right? So normally what you have to do is you have to write this. You have to say, here's a pure function, here's the input, here I'm applying the function in the compiler environment to the input, and there you go. But the point is that what you'd like to be able to do is just say function compile, and then just say, here's the name of the function in the compiler environment. Go get me a compiled code function.
It's very nice to do that. What Christopher's saying, it's very awkward to write.
So hold on. So this is the thing already declared in that compiler environment. The declaration doesn't, in fact, do compilation. It just says what the, okay. So with this thing here where you're declaring it to be a down values function. But now, couldn't you also say function compile of down values function of blah?
You mean like this?
Yeah, I mean, well, with some
although you might need the typed. I think that would make some sense. I'm not sure. No, that doesn't work. And it gives an absurd error, but yeah. I'll make a new notebook to put that in. But yeah. So I think that could work.
Okay.
But I mean, the point is here, it doesn't even matter. It doesn't matter if this is a down values function. This could be anything. The point is just that you can compile the function by name. And the reason why that's really useful, you'll see with the compiled component stuff, which is why I wanted to talk about this first. But there's this idea of a function that isn't implemented, but one day would be very nice, which is has various tentative names. But the idea is basically this is the function for compiling something and putting the results in down code.
Yep.
Right. So this is the most obvious base syntax, like most verbose syntax is here's where I want you to put the function and here's the implementation of it. So this would install this, it would compile this and install it into my function, the symbol of my function. But then the point is what you want to be able to write is stuff like this and stuff like this, where you basically just say, take the thing in the compiler, compile it and put it in the top level.
Could you show the syntax of install, the old 35-year-old install function?
It's horrifyingly simple.
It's a file. I mean,
well, it is because it uses the intermediate,
the template stuff.
Yeah. Okay.
Well, the template stuff is just how the thing's built. I mean, you could write a raw thing in theory. But...
Okay, so this is a binary. This is installing a binary. And it in its install actually does what you're wanting to do here. That is, it inserts something into the down values.
No, it doesn't. It makes down values, not down code.
No, I understand that, but it inserts something. If you say install of add to, it will actually assign values to add to of I underscore integer, j underscore integer, and so on, right?
Yes, that's exactly what happens.
Whoops.
Which is actually pretty nice.
Well, I'm a little confused, but
you run the install?
This is probably some
install.
This is probably something about context in stock notebooks.
This in yes. Well, this is a bug. So Aubrey, this is for you, please.
Understood. I'll report it.
Slides that have weird quotes around it. Very strange. Okay. Right. Well, in any case, the nice thing about this is you'll see later, I have an example with a compiled component where it uses syntax a lot like this and where it just makes things extremely simple.
Well, hold on. Let's talk about this function here. Okay. So how does this, what's another thing that's like this? I mean, we've got, this is essentially an assignment. This is a thing that is meta programming, modifying assignments, basically.
Set delayed is a bit like this.
Right. Well, so here's the thing. So the reason why, this is in blue because it isn't implemented because it's not for 13.2. And the reason for that is because there's a whole bunch of complexity around basically the fact that right now we don't let people define down code for stuff. And so if we do, there's some stuff. I mean, for example, how do you clear it? And where can you find out about its existence? You know, like for example, presumably down value. I mean, right,
that's what
different
link
options.
patterns in install. That's what link patterns was for, to figure out what the heck had happened.
Right. Well, maybe install. Maybe then that's actually a reasonable. I mean, it's a little antiquated, but it might be a reasonable thing to look at. To
Yeah.
But because I mean, one of the issues is right. So one of the options was maybe it should make a fake entry in the down values table that sort of makes it look as though it has a down value that
I think
calls
that's what
a compiled code function.
that's
but
exactly
it can't
what,
actually. It can't actually have that in the because the down values will override the down code.
I understand.
Another option
what
would be
install does is it has a thing that has a thing called call function or something, and it puts into the down values a trivial pattern match whose right hand side is call function or something.
Right. Okay.
I mean, so it's still going through the pattern matcher, which is not good, but it's but that's how it does it. So having a faux entry in the down values seems right to me, because then if you clear the thing, it'll clear everything, including that faux entry.
Yeah, you might want a way to restore. I mean, there's a little bit more, but yes, I think that's all not crazy. So,
well, I mean, there's some down values metaprogramming that we don't really support right now that involves manipulating, reordering, et cetera, down values.
I think we do support that if you actually write to down values of foo.
Yeah, you
absolutely.
You can do that. Yeah.
Okay.
Right. Well, I think this is not the time to go into this thing.
Okay, fine.
But
so let's keep going.
Yeah.
But the down
But I mean,
value function is a thing, but it's incompatible. So
Sorry, down value function is what?
So I think this proposal is to support down values function in 13.2. Christopher,
yeah. But the reason we bring it up is because there's this thing that changes the current syntax.
I don't
because
think
right now
a huge number of people are going to be hanging on that.
Fine. Yes,
that's
good.
what I think too.
That's what we
so,
think. Yeah.
Okay,
We
good.
saw that.
I mean, I think
right.
you might try and put in a bridge message that says something that is not completely crazy. In the case where it has a symbol there that it can't find, which is what's going to happen.
Yeah, that can make sense.
Okay.
Right. Okay, so compiled components.
Yep.
So basically compiled components it's essentially the package. A compiled component is a package for the compiler. And right, that's all it is. So let me just go down this. I have a sort of demo here. So, okay, the first thing we're going to do is just basically append to a component. And here the component doesn't exist yet. So I'm just appending to it to create it. So if I append to it, we have this compiled component object. Here it is. I can also
it's
get
a little
it
confusing
like this.
to create it at first by doing an append to, because obviously, usually append to can't do that. I mean, in other words, that there isn't a create compiled component function.
Right. Well, the issue is that if there were a create compiled component, and if you had to call it, it would mean you have to do really weird things in your packages, which is one of the problems with the old component system. So in particular, let me.
By the way, if we're talking packages, how come Connor isn't here?
Well, he could be, but also this doesn't actually involve really much interaction with the, it uses like the Paclet system, for example, but it doesn't really require any integration from that side.
Right. Todd's here. I mean, it's a Paclet, right? Yes.
All right. Okay.
So the reason, for example, this is a Paclet I was going to show later. This is sort of like a grand use of this stuff that works very nicely. So you see here, this is pretty typical. I have the base file, and then I have several sub files where the actual component append to is happening, right? So you see in this file operations,
very
I
old-fashioned
call this
using .m files instead of .wl files, but Please continue.
Yeah, well, so the issue is that, see, that file gets run when you run needs here. So if you needed to create the compiled component, you'd have to do it here, which is just so bad. I mean,
Okay,
and
hold on,
also
hold on,
confusing.
hold on. Because the file, okay, explain what's happening inside the GEOS core base. Wait a minute. Well, GEOS core base has an append to in it. Is that right?
Yes.
And why couldn't it have the create compiled component in it?
Well, I suppose base could, but then that would mean that base is assuming that it's the first thing to run.
Yeah,
It means if you reordered these, it would break, which would be
it forces
even more
you
horrific.
to really think about what order. What we have here, it doesn't matter what order anything's loaded. You see, it's just definitions. It's very convenient.
Well, I don't like the name then append to. I mean, maybe couldn't it just be add compiled component or something?
Well, an earlier name was register compiled component. But yeah.
See, but the point is, it's not really what it's doing is it's throwing more things in the bucket that's called my component, right?
Correct.
Right.
And there might be 0 things in that bucket initially.
Well, it might not, in the design, it might not even exist.
Yeah.
Right. So one analogous thing, by the way, is compiler environment append to, but you do have to call create compiler environment.
Well, there always is one. There's always one. So
yeah, I mean, you can call it with one argument, but that just defaults to $. The point is, this will never create a compiler environment.
Yeah, which is why I don't think the other one should be called append to. I think it should be.
Well, one thing that maybe would change it a little bit is if you run this on some new component that doesn't exist, and this is actually a topic that we're going to talk about later. Right now, this returns a failure, but this could return basically an empty component, right? And so what that would mean is that, it's sort of like all components exist, they're just all empty until you append to them. That would, by the way, be fairly consistent with how Paclets work, because Paclets, if you just do something like that. Oh, maybe not. I thought there was something where it returned an empty Paclet object, but I guess not. Oh no, it's like this, it returns an empty Paclet object.
Okay, so the issue here is you've got a bucket. It might not have anything in it. This might be the first mention of the bucket. I don't know. Somehow I bet it's probably the wrong name. Compiled component addition. I don't know why that's the right name. It might not be.
It sounds too noun-like.
Yeah.
I mean, we could say something like declare, which is sort of a pun because it's like you're declaring the component, but you're also declaring that this thing is part of the component.
That's not crazy. Copy in 1 in 33 and.
No, we have in the old component system, there's something called that, but that's okay.
Yeah, we could get that's not a problem, Christopher, I don't think.
Yeah.
I mean, it could be declare compiled component as well.
Yeah.
Put a payload in it.
I think that's quite nice. I mean, I think declare compiled component is the.
Yeah, okay. I think that sounds good.
So long as that's consistent with the other declares that you have.
Well, I don't think there are any. There are a bunch of declarations. There are no other declares.
Yeah,
is that consistent with the other names? Do you have other names that have compiled component first? I mean, I really don't like the verb first style of naming. Declare compiled component. Yeah.
Well, I think it was build compiled component and load compiled component, but they could be compiled component build.
No, I don't think they should be. I think that these are cases where, like, create comes first. I think there are things, Todd, where I agree with you that it goes, noun verb, but I don't think these are examples of that. I mean, it's subtle, and I agree it could go either way, but I think this is slightly better.
It's slightly easier for searching if they're consistent.
Well, I think it's better to do it this way around, especially
Fine.
since you've got, okay, we'll see the other functions that
Yeah.
you have around compiled components.
But by the way, on that point about searching, I feel like at some point we should get, I mean, a lot of, IDEs and text editors and things, they won't just search from the beginning. If you type compiled component, it will
I know.
get this too.
We've been supposed to have that forever and ever. It's been postponed multiple times. It might make it to 13.2.
Right, but that's an argument to not
Worry about it.
choose function names. But yeah, right.
The-
But okay, so basically, okay, if you append to it, or okay, if you declare to it, then now you've got this component. One thing, this is kind of an implementation detail, but the full form of it is just that. So this is just a reference to a component that is out there. It is not, and the reason for this is because otherwise, if this actually had the association in it, then you append to it here, and then you have this older version of it sitting somewhere else that doesn't have that declaration in it.
Okay, but when you save it in a file, what happens?
So the way you save, so I think if you just tried to save it in like an MX file, nothing good would happen. But there is a way of serializing it. But that's actually a reasonable thing to think about, is how do you
save it with a greater than put into a file?
Well, I mean, if you just did it like that, it wouldn't work.
What happens if you reactivate the notebook and things?
It wouldn't work. You'd have to run these again. I guess one thing it could do.
I mean, if it was in a Paclet, if it came from a Paclet, of course, it would work.
Sure.
Knew where the Paclet was.
Yeah. So one option is it could have, although I'm a little skeptical of this, it could have sort of a cache of the association in its second argument. It wouldn't ever display it, and you'd still be able to create them like this. But the actual full form of this would have, the implementation there. Now, the only problem with this is that, I mean, first of all, it might cause some issues with same queue, but I don't think people doing same queue on components is very common. The other thing would just be that you would have out-of-date versions running around. So like you would have something where maybe in my notebook, I have a few of these little compiled component things, and one of them I choose to rehydrate, but it's different from all the other ones.
But so look, it's a bit like the symbol table. You don't by default save the symbol table. This is another indirectly referenced name.
Correct.
Which is an argument to just have it be like the symbol table and not get serialized directly, and require that you do the equivalent of a save. I mean, the put won't work, but save could. Could save be made to work with this? I think it should.
This save?
Yeah, that save.
I'm not even sure I've ever used this save. I've used dump save. I've never used just normal save.
Well, I mean, it saves symbol values. It does the thing that get doesn't do. I mean, put simply takes an expression and puts it somewhere. Hey, hold on. I'll be back in just a second. Keep going. I'll be back.
Okay. But I don't really know.
I don't think it's very serializable. It's like a link object or.
Well, no, the components I think are totally serializable. I mean, they're just. I mean, like
what happens if it comes from a Paclet? You don't want to.
That's fine. It doesn't even know. It doesn't need to know that it came from a Paclet at all. I mean, it's just a list of declarations and things to compile.
I think if it came from a Paclet and then you serialize some different version of it, it would be all sorts of confusions will happen.
Oh, so that's true. Like if basically you wrote this component, so you're expecting it to come from a Paclet, but then you also have a serialized version of it in your notebook, and those two versions are competing. That could lead to weird things.
I mean, the full form could refer to the Paclet.
Well, but it can't, because I mean, we talked about how there isn't any $current Paclet thing. Like there's no way of knowing what Paclet you're running in.
Heather, what do you mean there's no, what does it mean to run in a Paclet?
It doesn't really mean much. I think that's sort of the problem. So, I mean, the point being that if you have, say, the Paclet says in its extensions, oh, I have this context, I define this context. Then the point is, well, there's some .wl file that defines that context. And the question is, in that .wl file, can you ask, hey, what Paclet am I associated with? But there isn't, I'm not sure there's really a well-defined way of saying what that associated with is.
I mean, we have this $input thing.
Right, input file name or something, isn't it?
Yeah, I mean, you can capture your the location of the .wl file at the time it's read in and save that yourself. But if you're just running some function defined in the .wl file, there's no way to say, where did I come from? There's no, dollar file that defined this function thing in the language.
But I don't understand, because we certainly have, when you're parsing from a file, you certainly can get $input gives you the name of the file, doesn't it?
Input file name.
And you can capture that. Lots of people do. They'll define some global variable within their package that captures the location at the time it's read, and then you can sort of manually use that. But if you don't do that, then there's no way just to sort of ask what Paclet or what input file did this function definition come from while it's running, unless you manually saved it.
I mean, we probably could capture that. How would we do that?
I'm not even sure though because I mean, the connection between a Paclet and the .wl file that we consider the implementation of the Paclet is pretty tenuous. And the Paclet itself is just a Paclet info file, which says something like, I extend this, this context, and then when you run needs, like I don't know, I think it's pretty hard to know which the connection between the actual implementation file and the Paclet info is pretty tenuous.
Fair enough. Okay. Anyway, let's keep going on this main review.
Right. Well, okay. So the basic point though is that this is a reference. It doesn't actually contain the information. It's just a reference. So that way, you can't have two versions of them sitting around that are different.
Right.
Right. But okay. So then you can append.
How does that relate? Entity store is another thing that works like that.
You mean just the entity store head or $entity stores or whatever it's called?
Well, I mean, the entity store has, it is an indirect thing where you have the name of an entity type, and then it isn't the entity type. I don't think. Let's see, the entity store maybe does have the content in it, but when you're actually dealing with an entity, the serialization is always, again, non-trivial, because you can have an entity of type foo.
Oh, sure. I mean, just basically that the entity object itself, doesn't contain any of the, it refers to this entity store, right?
Yep.
Yeah. And if you serialize this and deserialize it, it'll just be like confused.
Yep.
Yeah. That is analogous. Okay. But okay. So here, we put some declarations into it. You see now it says I have two declarations. So I'll show in a second how you use these declarations, but first there are some other fields in these things. So the first one is, right. So the first one is library functions. So here basically the syntax is if you want to add anything other than declarations, you do that with this syntax. So you say the component, then you say to what field you'd like to declare something. Because again, we're imagining this says declare compiled component, and then you give it, the payload. So essentially what this is saying is when we build the component, which we'll do later, this is just specifying something that we want to be included in the library that gets built. This is basically just saying, in that library, you should have these functions defined, where this is following the same syntax as function compile export library.
That last part is, but I don't understand that you had a thing previously where you said declare compiled component, and then could you scroll up because you were declaring it with literal code there. Yeah, with the function declaration. Yeah,
right. So that's declaring this is equivalent to writing this. If I could type. And what this is doing is it's just appending to the declarations of this component, right? This is so okay. The point is a component is just this basically inert container, and it contains information that can be used both if you want to basically compile something that uses this functionality, you can refer to this component. It can use all those declarations from this component. The other thing that it can be used for is that you can build the component, and then you get this built component library, and that component library can do all sorts of fancy things. Those are the two main things that this does.
But why is it don't you have a library function wrapper that represents a library function declaration? And why do you bother to have that second argument of compiled component?
Wait, so that the library function wrapper is a totally different thing.
Okay,
right. So
this declaration. Oh yeah, sorry, it's a call, right?
Right. So this is basically saying, so like, I mean, if nothing else, if I just say component, why is my autocomplete is being very strange right now? Oh, I haven't run this yet. Okay. So if I say this of all, this might help. So this is everything that's in the component. This is what defines the component. So you see, it's just this inert thing. There's a list of declarations. Here's an association of library functions. And here's two things that we haven't seen yet. And so basically, when we call build compiled component, which I do lower down, it's just all this is saying is that one of the things is to include. Basically all build compiled component does is it builds this library. And this is just saying, by the way, include these functions in the library. That way, when I call load compiled component, I have access to compiled versions of these functions. I'll basically get back a version of this association where these are compiled code functions.
Why is that person called declarations, not function declarations? I mean,
because they can also be types, they can also be compiled expression declarations, they can be whatever you want.
Yeah.
Any compiler declaration.
All right, fine.
Right. Okay. So let me just keep going here. So okay. So we have some library functions. This other one is installed functions. This is analogous to that function compile install thing that doesn't exist yet, right? But it follows the exact same syntax, which is sort of the reason I brought it up. So here I'm writing, here's the symbol name, here's the definition. Another thing that you can write though is you can just write, foo, where foo is something that was declared in the declaration section. And that will also work. Although here I don't think I declared.
What is an installed function? That's something that's going to be put in the down values.
In the down code, yes.
Code.
Down code.
Mm-hmm.
Yeah, and I have an example that I'll show in a minute. This is actually kind of the main feature that lets you do nice stuff.
Okay.
But it's sort of hard to explain till we get to the building part. The last thing worth mentioning quickly is there are these so-called prologues, which are basically just functions that get evaluated at build time, at load time, and at declaration time, basically. So the usage of this is for loading libraries. So if I have some functions that I'm defining that rely on some libraries or where, when I load the build of the component, I also need to load, OpenSSL or something like that. This is where you do that.
Okay, but it also presumably will give you a progress dialog if the load time is going to be large and stuff like that.
The load time is trivial. The build time can be long, but the load time is never more than, half a second.
Even if it was some weird machine learning thing that was giant.
Yeah, usually the load time is very quick because it's just loading a dynamic library. It's not compiling anything.
I don't even know what loading a dynamic library means. I mean, does it map it into some address space or something? It doesn't even copy any bits.
Tom probably knows more about what basically library functions.
It has to do a little bit of work, but modern OSs, it's terribly lazy. So it has to resolve dependencies. It can fail.
I love the way that the fact that it's terribly lazy means it's terribly fast. But anyway, never mind.
Yes. Oh, yes, correct. I mean, it does as little work as possible, basically.
Okay, all right, onward.
Okay,
so real quick though, so just something real quick. In that compiled component append to, why you have prologues, comma, and then some prologues, and you have installed functions, comma. Why isn't that install functions arrow, prologues arrow, right? And then you can have a whole bunch in one.
Yeah, I was wondering that too, actually.
Well, so one thing I was thinking about would be supporting some association syntax, because if nothing else, that means you could take the serialized version and feeding it here. The reason why I don't want to just do an arrow here all the time is, if nothing else, because there are things like installed functions, library functions, where if you give only one of them, it's a rule, right? So here I'm giving a whole association of them. Here I'm giving only a single one. And so it makes sense for this just to be a rule. And so if you allowed for their weird precedents, I mean, this just looks really weird to write.
Well, but if you made it an association, so library functions, arrow association. And then you can have as many of these things piled into one append to as you want. Different types of components.
Right, but you could also do the different types of components. You could also just support something like, you could support the I guess it would be a little bit inconsistent, but you could support that and then also just support this.
I agree with Todd that I think it'd be better to have these arrowed things. And I think that this is not, these things will be as often written by machines as by people. And the less obscure this thing is when you see it, the better. I mean, I think
the one thing about the pure rule form is they kind of look like options, right? The last argument to a function.
So why not just,
But you could group them in a list or an association, or you could just ignore the fact that they look like options and just use a straight rule.
Well, I'm worried that you may need options.
Right, and if we need options later, right, then we would have a problem.
So another thing to mention quickly, but I'm not sure this really affects it much. Let me show you a real example, because you often end up with, you often end up with long, the inside of here is something big. So here's an example where I'm appending declarations to GeoSlink. This is taking advantage of the fact that the second argument defaults to declarations. But basically, I'm giving it this list, but you can see, this is a long block of stuff, which sometimes I think can be awkward if it's on the right-hand side of a rule.
Maybe. I mean, you just put the rule up there and then an arrow, and then it hangs, then all the rest of it is nested. Doesn't seem that terrible.
Would it still default to declarations, though, if you just give it a list or a single item?
As long as it isn't ambiguous, I think it should, yeah. Why not?
Trying to think if there are any cases. I guess there are no declarations that take the form of just a rule. So I think it is unambiguous. Yeah, okay, well, I can look into.
It's pretty nice, by the way, the way that whole declaration thing,
It's incredibly nice.
Yeah, well, I'm going to show this example, the big example at the end. So this is spoilers.
Okay. Right.
But yeah, okay. So fine. That could use rules. I think that's fine. But now also, would it support this? I'm not sure how common this is.
I don't think it needs to.
It's not so terrible to put that in an association.
Yeah, I mean, if you write like this, I think it looks much better to put it in association than it does to have it just sitting there.
Yeah.
All right, let's keep going. I think probably the association. I would define the most encrusted form first, and
Crust.
What's that?
Decrust later.
Yeah.
Yes.
It needs to be smooth. Okay, keep going.
Right.
Can I,
Yeah,
can I
okay.
just jump in one more thing? Because did we
Mhm.
decide that declare compile component was the
Yes.
replacement for append to? The thing about declare compile component is it sounds like it's this just updates an existing compile component, right? It really is a kind of an add to thing. It looks like a overwrite kind of a replace kind of operation, doesn't it? Declare compile component.
Yeah.
There's nothing in that
Yeah.
name that suggests it's adding to something.
Well, maybe compiled component declare might be mildly better in that sense. I mean, it's like,
Well, I
because
like
it's
that
not-
better for other reasons, but I'm not sure if it changes my thinking on the.
I think it does slightly. I mean,
Well, because declare compiled component, it's very clear that the thing you're declaring is the compiled component, as opposed to compiled component declare, where it's a bit of a pun about whether you're declaring the component or whether you're declaring things that are associated with the component.
Yeah, I suppose, but I don't know. I prefer the verb now. I mean, the
Yeah,
noun
okay, but
verb.
append to is not going to
naming
work
anyways.
because of the initial.
Yeah.
It's very hard to have something which both represents, you know, if there was nothing there, start it and add to what's there.
Yeah,
I mean, I
words
think-
like register and things are kind of are suggestive of that, where you're just sort of adding into some state.
Which is why register compiled component was another possibility.
Yeah, right.
Well, it was in the original thing. It was, but
What do we use register for elsewhere? I mean, we have register for entity stores and things like that.
We have register for Paclet sites.
Does it mean the same thing?
Yeah, it means add to a list of known Paclet sites. It's like
That's a little
updates the
different
data
from this.
structure.
Yeah, I know, but
Yeah, it's right. This is more like adding to this compiled component. It's not registering a compiled component in some
Right.
global data.
Okay, we're gonna run out of time, so let's keep going. We got to
Yeah, okay, let me go to the examples, but right, okay, so let me skip down here. Okay, so the first thing is how you use components in other compiled programs. So we have this compiled component. One of the things it defined was this myfunc thing. So, you know, if I compile this myfunc is defined, but you can use compiled component as effectively a declaration. So this is the slot where you'd put things like function declaration, type declaration, whatever. You can also just use this and it effectively, you know, and you could put it in a list, include other declarations too, but this effectively is just a big ball of declarations when you use it in a case like this. So here, you know, myfunc is defined. Similarly, if you wanted to include this in a compiled component, then, or sorry, in a compiler environment, you would also just run compiler environment append to, and just like any other declaration, you can throw this in and it will, you know, put it into the declaration. So
is the content of a compiled component always declarations, or can it be other things?
it has other things too, but declarations are the only thing that's relevant for doing compilation.
I see.
The other things are relevant for sort of
Like the
interaction
library.
with the top level. Yeah, with the library.
Okay.
So yeah, so basically just it behaves like a declaration in all these contexts. Okay, so the libraries though are the big thing. Okay, so there are basically two functions, build component, compiled component, and load compiled component. So if I call build, it will go off and it will compile it. Ignore this message just because I'm using some internal version of the Paclet. You see it ran the prologues that might have, you know, loaded the libraries and so on, and it returns a success object, and it tells me, you know, where it was built and so on. By default, it builds into like that place in the user base directory where create library dumps things. So it kind of just gets dumped in this central area that find library can find, but which is sort of, you know, yeah, like a scratch space area. And now to load it, so there's you can
sorry,
explicitly.
that presumably you have an option that puts in a different place. Is it like?
Yeah, it's a second argument, and it's
I see, okay.
a little bit below. In fact, the most useful thing is you can give it a Paclet object in the second argument, and it will put it into the Paclet in the correct directory and so on.
Cool.
But okay. So the thing that this does though, so you can load it explicitly by calling load compiled component, but I'm going to show a different way of loading it first, which is that when you call, declare compiled component and you declare some installed function, when you do the declaration, it actually sets a down value for that symbol. So above, we ran somewhere we said, yeah, installed function, we added in, this installed func1. And when we ran this line, it added a down value for installed func1 that looks like this. And I mean, actually, this could probably be a bit cleaner, but basically, this is just loads the compiled component and then tries to, call the compiled version of this. So this is very analogous to how Paclet auto loading works, where the symbol will have some sort of definition that's kind of a placeholder, but once you use it, then it will actually do the loading. And so if I then run this, you see it ran it loaded the thing, and now it's defined. And now when I run this again, this is just calling the downcode definition of this symbol.
Why is that thing blue?
I'm not, so it seems to be inconsistent about whether it's blue or not. It's blue because there are no down values for it, because it just has down code. It seems when I do this, when this is defined in a Paclet, so it's in some context as opposed to global, it doesn't turn blue, and I don't really know why.
Yeah, it's something to do with the syntax coloring, but I'm sure that can be fixed.
Okay.
Yeah, but the point is, this is just a downcode function now. Right, and so alternatively, that could have been loaded by calling load compiled component, which does the same thing, but which also returns other stuff. So for example, it returns the library functions, which includes all those library functions that you asked to be compiled. So that way you can ask for things to be compiled, and then you can access them later through this. And it includes whatever it happened to install and stuff like that. One other nice feature is if the component that you have in memory gets out of alignment with the component that it loads, it can let you know, which is sort of a nice feature.
Okay.
So let me maybe show a Paclet example because it makes it clear what's going on. So actually, I'm going to show the fancy Paclet because
show the nice one.
We're running out of time, so
yeah. So okay. So here's this is a fresh kernel. This is a different kernel from this one. So this right. So here, actually, let me make sure it's a fresh kernel. So I have this Paclet geoslink. It defines a compiled component called geoslink, and for some reason this notebook is hanging. Like it's just now we're back. Okay, there we go. So now I've previously, it's very strange. Okay, well previously I built this. It's not even actually not responding. It's responding just fine. So I don't know why it keeps thinking it's not responding. Okay, I'm gonna reopen this because it's just being broken. I
mean, this is a very streamlined way to get significant functionality from what's built with the compiler.
Yeah. So okay. So basically, what I'm going to do is I have this Paclet. It's already been built. I Paclet directory load it, and I run needs. So that's for a normal Paclet. That's all you run.
Mm-hmm.
And now, in order to do it, I don't have to run any kind of load the Paclet, anything like that. I'm just going to call geos initialize, which is this is a geos function. This isn't a function that I define. This is an installed function that calls some C code, whatever. And the point is that geos initialize, when I run it, it will automatically load the library. And now all these functions are, defined, and I can, do whatever I want. And the only reason, just to be clear, because I just realized this might be misleading. Geos initialize is not something that like loads a component. This is just that Geos has a function that needs to be run. Yeah. So
Which you
basically,
could have put in your some kind of prologue if you wanted it to be auto run whenever any other function from the Geos library is run, or is that not true?
No, you couldn't put it in the prologue. Maybe we had a discussion of maybe having a thing called epilogue, which might be able to do something like that, but I have to think about it.
Seems useful to be able to have, because I think a lot of external libraries will have something that requires initializing them. And so it just seems like if you're calling a function from within the external library, like this Geos boundary thing.
Right. Let me just make a random note about that. But right. So the point though, the main point here though, is that from the perspective of the Paclet user, it's as if these things were defined with set delayed. There's no visible anything that these are, involved.
Right. So can we see the source code of the like from Geos and things like that? It's over there.
Yeah. So basically all you
library
write
declaration. Yeah, go ahead.
This is just a list of declarations. So basically I'm saying, measures saying, okay, append to, I want, all these declarations. And so these are things, this is just standard compiler stuff. I'm saying, I want Geos area. Here's this declaration. A little bit lower, I have a function declaration that defines a function called Geos area. And it's got some implementation that calls the library function.
What's that exception code thing?
This is an unfortunate thing. This is basically just because we don't have an exception mechanism in the compiler right now, or at least not a documented one, basically because there isn't a top level exception mechanism to emulate. And there's enough talk about maybe having something like that from the error handling stuff that we don't want to invent one.
Fine.
Exactly.
So yeah, so this is sort of in limbo right now. But okay, so I'm defining all these, all these functions.
Something like the name dist pointer. Is that a C language name inside the Geos library, or what is that?
Where do you see dist pointer?
A little bit higher up, or G1, G2, whatever they are.
I mean, these are just argument names to the function.
Oh, I see. Oh, I see. Okay, fine. So
and then, Geos disjoint is the function in Geos. Yeah. Right. So in any case, I declare all these functions, and then I just say installed functions, bang, and there's a big list of names. And then when I call build, it just knows, okay, I'm just going to build all these functions and, put them in the library. And then when I load the thing, anytime I refer to one of those symbols, it will load it and it will, have the implementation there and everything.
This is very, very nice. But I mean, so within a Paclet, a typical thing would be that those symbols will wind up in some fairly private context that can then be sort of fished out of for various uses.
Maybe they might be the exports from the Paclet. They are, look at the Paclet info here. They probably are in this Paclet. Maybe they're.
I don't think I mentioned them, but they're mentioned through the context.
They're exported. These are the exports. Oh, look in the geoslink.env then. Maybe they're.
Oh, sorry, yeah, sure. They're listed here. Yes. Right. So I mean, these are just
the exports. Right. These are the exports from the Paclet. They're not private. This is, it. And going through downcode is so frigging fast.
No, I understand that. I'm just saying that in terms of what happens when we're writing code, I mean, you don't want to spray these things into the system context or into the global context.
But they're in a package.
No, they're not. I mean, these are just symbols. There's nothing special about them. When you call, one of these things here, it's just like calling set delayed. It's just a symbol in whatever context.
In whatever context it's naturally in.
Yeah,
correct.
Yeah. It's not doing any parser wizardry or anything like that.
Well, so I mean, the real thing here is the translation of data structures, which I suspect is non-trivial. Right. I
mean, that's the big file. The big file, which actually does the conversion between a Geos multi-line string and, a line expression.
Does it actually work? Does all this stuff actually work?
Yeah, totally. I have a great example of this. I mean, I think that the eventual use of this particular package is, I think Jose talked about wanting it for geopolygon operations, but I had an example that I was working on just like a couple days ago, where I had like 72,000 census tracts, which have like millions of vertices or something. Actually, not millions, but it's like 100 megabytes of geometry or something like that. And I was doing things like, computing the region union of 20,000 of them, and it runs in like half a second. And like region union, that takes like hours. So
Right.
but the other important thing is that I had operations where I'm passing these things back and forth many times, and as a test I tried making it serialize and deserialize at each step, right? So basically it goes through this code of turning it into an expression, then turning it back into a geos thing at each step. Even though there was like 100 megabytes of geometry, it does that, that back and forth was negligible. Like it was like took, 0.05 seconds or something like that, doing it like 5 times. So it's very, very efficient.
Well, that's great. That's great. So, I mean, look, this is now, this is becoming a major use case of the compiler is library linking.
Right. Yep. And then the whole point is with compiled components, it'll actually be, there'll be a way of making a Paclet that does the library. Because the issue right now is that we don't, without compiled components, there isn't a good way. If Jose says, I want a library, I want a way of calling geos with the compiler, I can give him a notebook that has code that he can run, or I can give him a .so or .dylib file that he can call library function load on and get back a big association of functions. Right. But this is the only way to be like, just call needs on this and you have a bunch of symbols.
Right. So you can include it in a Paclet. And so in the Paclet repository and in the function repository, it becomes possible to just incorporate functions that make use of external libraries like this.
Yeah. Yeah. Now there's also some interesting stuff. I mean, we haven't really thought much about this, but for something like the Paclet repository, we could imagine having some kind of service for basically we run the build compiled component, right? And we can run it on all platforms and stuff like that. But I haven't, I'm just mentioning that, but we haven't actually done any work about that. So I don't know how possible it is.
Well, I mean, we have a system, there's a slightly older version of this component system that we've been using for several versions, like to create libraries for the kernel. And they integrate really well with our Team City. That's all been figured out. So that would be a way to use our.
I have to disappear in a moment here, but
so what do we do? What do we do with this? Because it's very nice.
Well, I think we get it too.
Yeah.
Good.
And I mean, it looks pretty clear. I mean, it looks, it's somewhat complicated, but I mean, how could it not be? I mean,
correct.
Given what it's trying to do. I mean, I think the big thing internally to the company is, I mean, I know we've been looking at various libraries and people have been spending ridiculous amounts of time integrating those libraries. It's now kind of, this makes it, we should be figuring out what libraries people want to integrate and making sure that all this works smoothly with them.
Yeah.
Yep. And I see a question on our live stream about WebAssembly and GPU, TPU stuff and so on. That's a different direction in the compiler, also being worked on.
Correct.
All right. Looks good. Okay. Anything else we need to cover?
No, I think that's good.
I don't think so.
Okay.
Good stuff.
It's very, very, very nice stuff. I mean, and this is very impressive. I mean, I don't know how long this GeosLink thing took. This looks like, I mean, was this fairly straightforward to do?
The main part of GeosLink, like all this conversion code and being able to, call arbitrary functions took about a day and a half. And then, I've since then done little things of just adding little functions, but adding functions is like trivial. Like, for example, the other day I added these, prepared geometry functions. And it's just like, you just write the declaration for the function in C, and then, here's just a trivial thing. It's just converting, if it returns a 0, that's false, right? I mean, it's pretty simple. So, I mean, the only hard part was writing the conversion code, But again, that took like a day. So
What kind of documentation do we have for people to understand what on earth to do here?
do you mean how to use the compiled components or how to use?
Yeah, well,
Examples would be by
No,
example.
examples of how to take a random library and, think it like this.
There's a tutorial that I wrote in the last version that has a simple example with OpenSSL and a much more extended fancy example with SQLite. So this is the place to go, but of course this doesn't use compiled components. I think we'd want another tutorial explaining how
A
to use
different one, similar, but yeah.
Yeah.
Looking very good. Looking very good. Yeah, I mean, terrific. Yeah.
All right.
Hey, by the way, Christopher, are you in there's a meeting later that is, I think is finishing astronomy and geography. You might want to join that.
I have some other meetings later, but
Okay.
I can try and join.
Okay. All right. Sounds good. Okay. See you all soon. Thanks a lot.
Cheers then. Okay, bye.